So there are many talks in C++ conferences or across any tech conference about libraries or about tooling, which say, here's feature number 1, here's feature number 2. I'm going to tell you all about them. I'm going to walk you through step by step what this library, what this tool can do. And those all have their place, but I want to try something a little bit different for this talk. Instead of just walking you through what the tools can do, I want to actually build something which is interesting and which you could actually achieve something with, and I want to do it live. So I came up with some goals I wanted to achieve for this talk. I want to develop a small cross-platform application live. This is a cross-platform tooling talk. I want to target Windows and Linux, because this is at least a real-life example of what you might try to target, but I could do it in a talk. I want to demonstrate how you could handle dependencies. So I need at least one library which I need to pull in and link against for my program to work. And I want to build something powerful. It's not going to be just a silly toy Hello World example. I want to build something which makes people say, wow, you can actually achieve this in an hour with these tools. And that is the tough part, is I need to do it all in an hour. So, I had to think, and I thought, what could I build in an hour which has all of these things? And I came back to what I usually do, which is, I could build a compiler. What could possibly go wrong? So maybe an alternative title for this talk, instead of tools to ease cross-platform C++ development, write a compiler in an hour or cry trying. This is what I'm going to try and do today. Source language. So a compiler has a source language and a target language. The source language is what I'm taking in as input, and the target language is what I'm generating. So the source language could be C or C++ or Fortran or whatever. And the output language, the target language, could be ARM or x86. It could even be C or another kind of actual source language. Real compilers do this. So my source language for today is this. Can anyone tell me what this language this is? Brainfuck, yes. So this looks weird. This is actually one of my favorite languages. And I'm not making a joke there. This is real, because this is a really simple language with a very small set of instructions that I can realistically build a compiler for in an hour. So I'm going to kind of introduce the language to you so you understand enough to follow along. And you should understand pretty much the entirety of the language. So it essentially operates on this infinite tape of zeros. Every zero here is a cell of memory. So it's just an infinite linear tape of memory. And these are all characters, 8 bits, 0 to 255. In addition to this memory, I have a pointer, which here is my caret. This is kind of just like a classical Turing machine. You have an infinite tape. You're doing some kind of symbolic manipulation. You have a tape head, which is tracking along, reading things, writing things, doing computations. We have 8 instructions. Each instruction is a single character. So the first one, does anyone have an idea of what this instruction might do? Exactly. Moves the pointer one place to the left. So we can do this instruction multiple times and move our pointer over. If we want to move it back, then we use this instruction, which moves the pointer right. So we can keep on stepping, and eventually we get back to where we started. How about this one? Any ideas? Increment. Yep. So this language, it looks weird, but it's actually pretty sensible in a lot of ways. We can just increment whatever we're pointing at. And if we want to decrement it, we use the minus instruction. A little bit less obvious are the I/O instructions, comma, which reads a character from standard in. So we could read, for example, whatever 3 is in ASCII. And then we can write it to standard out with dot. So these are our 2 I/O primitives. And the last 2 instructions lets us do loops. So this means we're going to repeat whatever is between these 2 square brackets while whatever we're pointing at is greater than 0. So as an example, if I put a minus, which is the decrement instruction in there, this would just keep on looping down until we get to 0, and we end. And that's the whole language. Does anyone have any questions about this before I move on? Yes?
When you increment 9.
When you increment 9, I mean, these are all zeros just for demonstration purposes. These are 0 to 255. So in like proper compilers and interpreters, I think you wrap when you get to the end. I don't think I handle that here because I have an hour, but you know. My target language is going to be x64, which is the 64-bit flavor of x86 assembly. I'm not going to teach any here. We're going to be using a very small subset, and I'll kind of explain it as I go along. So the tools I'm going to be using today are these: Visual Studio, CMake, WSL, and Vcpkg. If you don't know what any of these are, don't worry, I will explain them. Obviously, I'm coming from Microsoft, so these are the tools I'm going to talk about. Some alternatives: you could use Visual Studio Code or C-Line for IDEs, Meson, Build2 for build systems. These are all some alternative tools you could use if you want to apply these kind of concepts, but you don't like the tools for some reason. So that is enough for our introduction. Now we can get started. So I'm going to tab out and open up Visual Studio. Okay, so I said we're going to start from scratch, so we're going to create a new project. And as I said, we're going to use CMake. I mean, CMake is CMake. It has its issues, but it's essentially the de facto standard for doing cross-platform C++ development. I'm going to call it Lame Duck, because I'm a terrible person. And here we go. We have a very simple CMake template. So you can see kind of where we're standing. We just have a project with a single subdirectory. Can hover over, and we get a little tooltip, which you probably can't read, but it just tells you a little about the instruction. And then in our subdirectory, we have a executable, single executable, which builds from this source file. And the source file contains a very simple hello CMake example. So just for sanity's sake, let's build and run this, and we should see, there we go, hello CMake. And now we're going to get started on building our compiler. So get rid of all of this. We're going to have 3 stages in our compiler. We're going to compile, we're going to assemble, and we're going to link. And we're using functions, so this is functional programming. That's not true. So we're going to have 3. We'll just keep them empty for now. Okay, so we're going to start off with compilation. So the first thing we need is we need an input file, which we're going to read our code from, and we need an output file, which we're going to write our assembly code into. So you use ifstream in, and for now I'll just use hello.bf, and we'll put something there later. Similarly, we'll have an output stream, and we'll just call it temp.asm. So this is where we'll write our assembly into before calling out to our assembler and our linker to eventually give us an executable. Now you'll note that our IDE here has very helpfully told us that we don't have ifstream available, but it can actually add the header for us now. This is a relatively recent feature in Visual Studio, but it's quite handy if we just want to use something and let the IDE worry about what to include. Okay, So we have our two files, and now we can get started with our compiler. Now, because the input language is so simple, as I said, it's just characters, each character is an instruction, we can just loop over every character, and for every character, we'll write out some set of x86 instructions. Does that make sense? So we just have char_c, and while we read characters, we're going to switch over C. Now, the 8 possible instructions we had were right, left, plus, minus, comma, dot, and the loop instructions. Now, Visual Studio has this nice handy multi-caret editing. So if I hold down Shift and Alt, I can actually go and write all of this stuff in essentially a oneer. Saves me some typing, quite handy. So I've got my cases, and I'll stick in a default as well. Okay, so now we are ready to start outputting code. We're going to start with these 4 instructions because they're pretty simple. Now, as I said, the language is an infinite tape of zeros and a pointer, which is going to move right and left as our program executes. So what we need is somewhere to store this pointer. And when we're executing right down, when we're writing assembly, best place to store that is in a register. So I'm going to store this in R12. So our output instruction just looks like this. Add into R12 the immediate 1. Does anyone have any questions about that before we move on? Oh, good. Hopefully, even if you've never seen assembly before, it's fairly self-explanatory. Similarly, for moving left, we just subtract 1. If we want to add into here, then we need to essentially indirect through our pointer. And we do that using these square brackets. And this is just saying add 1 to whatever R12 is pointing to, which in this case is our cell here. And then just the same, we can subtract 1. So those are the 4 very simple instructions. We can go ahead and build our compiler. Succeeded. Okay, so I'm going to use this compiler from the command line because it's just much easier to work with. So I have this extension called whack terminal, which is just an integrated terminal into Visual Studio and saves you having to have another terminal window open to do all of your command line stuff. So if I run out/build, there, of course, out/build/ lame duck. There we go. So that has run our compiler, and we now have our empty assembly. Why is this empty? Pardon? Sorry, I can't hear what anyone's saying. Yes, correct. We did not move our input file. So I have hello.bf here, ready and waiting for me, which I can just move in. Oh, move is not, I don't know how to command line shell at all. Here we go. So this is a sneak peek into WSL. But our hello world is just this. Don't have to worry about what it's doing. Just trust me. It's a hello world program. It will be fine. So we can rerun our compiler, and hopefully we will get, there we go, something which looks like x64 assembly. So now this is targeting Windows, but I said we want to make a cross-platform application. We want to target Linux as well. And in order to do that, we're going to delve into Windows Subsystem for Linux. So this is pretty much as it says on the tin, it's a subsystem in Windows for running Linux distributions. So it wants you to be able to install Linux distributions easily, not just like some fakey Linux environment, like actually install Ubuntu or Mint or Arch, things that you're familiar with if you're coming from a Linux background. And we will run bash shell scripts and Linux command line applications like Emacs or Ruby or SSHD, any of these things which you're familiar with from the Linux world. My favorite thing is we can now use Linux package managers. I can use apt or pacman and actually install software and have a productive developer experience on Linux inside Windows, which is really, really nice. And I can even invoke Windows applications using a bash shell. And if you just saw how I completely failed to move a file inside CMD, you know that this is really, really great. I can use a bash shell and invoke my Windows command line applications. One thing to note is it's not a VM. This is not something which is going to take a while to spin up or use a bunch of resources. It's a compatibility layer which just maps the Linux world into the Windows world. So it's pretty performant in most ways. File system performance is not great, but most of the time it's there. It's very, very usable, very fast. And installing is as simple as running this PowerShell command and then getting whatever distribution you'd like from the Microsoft Store. Question?
Could you say that is basically the inverse of wine?
You say this is the inverse of wine? Yes, pretty much. So if I've already ran that PowerShell command. Yep.
How does it compare to Cygwin?
How does it compare to Cygwin? Well, Cygwin is trying to give you a kind of Linux shell in the Windows world, and you get a whole lot of problems like path mismatches between Windows and Linux styles. This is actually a Linux distribution sitting in your Windows machine. I mean, it doesn't have the Linux kernel yet. That is coming, but it's as close as you can get to actually running Linux inside Windows without like running a VM and all that nonsense. So if I go open the Microsoft Store, the page could not be loaded. Just trust me, you can download a bunch of Linux distributions, and I have installed Ubuntu. So this is just what you'd be used to if you run Ubuntu as a developer machine. I can run ls, I don't have to run dir. I can run, find, gives me a bunch of files. I can run gcc. I can run apt, can search for Clang. Essentially anything which you're used to in a Linux environment, you can do from WSL. So now I have WSL up and running, but I want to target it from Visual Studio. Now in the past, you had to do a bunch of jiggery-pokery, like set up SSH server and type in all your configurations and things like that. But it's got a lot easier in VS 2019. So this is the new CMake configuration UI. So it used to be you would just edit JSON files by hand, but now we've got a nice little GUI, so you can modify this all without just writing JSON. So you'll see that this is targeting 64-bit MSVC. Now, if I want to add WSL targeting, add a configuration, and down here is WSL debug. This is now targeting 64-bit Linux. If I want, I can actually run address sanitizer from Visual Studio in Linux. And I can change any CMake variables I wanted here. So if I go ahead and save that, then change configuration. This is now running CMake inside WSL, and all I did was add a configuration and save the file. So this has found CMake. It's even found my Vcpkg installation, which I'll talk about later. and it's generating Unix make files. I could make it generate Ninja if I wanted. So it's generated, and it's going to start extracting the information from the target. So soon, hopefully, this little thing should go away. There we go. Perfect timing. Okay, so now if I hit Control-Shift-B, I'm now building for Linux. Succeeded. And if I type WSL, I'm in my bash shell. I can now run /out build WSL, and that runs my Linux application I've just built question.
Is it located in the same folder?
Pardon?
Is it different?
Yes. So this is in the question was, are these in different folders? Yes. This is in outbuild WSL debug. The other one is in outbuild x64 debug. So this is generating the Windows binaries in here and the Linux binaries in here.
But they are side by side.
They're side by side. Yeah. So I can just as easily, like I mentioned, you can run Windows applications from the bash shell. So if I just switch this to x64 and I did .exe, I just ran the Windows version. And you can see these are different if I run file. This is an ELF file, which is the Linux binary for GNU Linux. And if I run file on the exe, then it tells me it's for Windows. So these are actually binaries built for different systems, but I can run them from the same place, which is really, really nice. Okay, so I can now build for Windows, build for Linux. We're good. Let's keep going on our compiler. So for output and input, I'm going to kind of cheat. You could do this with system calls, but it would be a nightmare on Windows because they're undocumented and it's just not fun. So instead, we're just going to call into libc. So we're going to link against libc and call getChar to get a character from standard in. That's going to put the result in the AL register, so we can just move into R12, into where we're pointing from R12, the result of getChar and break. Similarly, for putting a character, we're just going to move whatever we have in R12 to CL, which is what Windows expects arguments to go. We'll deal with Linux in a little bit, and call putchar. This all okay? Any questions? Nope. Great. Okay, so a little bit more complicated is loops. So loops, like I said, if we have some instructions, what we're going to do is when we get to this instruction here, we're going to check if what we're pointing at is 0. If it is, then we finished the loop, so we're going to jump to the end. If it's not, then we keep doing all the instructions in the middle and then jump back to our check. Okay? The problem is these can be nested. So we essentially need to be able to match up our begin and end loop instructions. And we can do that with a stack. So hopefully the standard library comes with a stack. So we can just keep a stack of all the labels which we've written out to jump to in our assembly and push and pop those as we find them. Then what we need is a start label, and we can ask our ID to give us the stack include. Okay, we're all green. So now we need to start writing out our code for here. So what I said was we want to check if what we're pointing at is 0, and if it is, we jump to the end. And we need a way to jump back to the check. So we need to have a label in here. And we're just going to number all of our labels with some integer so that we can find where we're going to jump to. Then we need to do our check. We're going to compare what's in R12 to 0. And if it is 0, then we're going to jump to the end label, which we'll just call label number end. Break. Spaces after label. No, because this is all going to be one label name. This is going to be like label 0 end or label 5 end. And the 1 2 lines up is going to be like label 0 or label 1. Yep. So similarly for the end, when we get here, we want to jump back to our original label, which will be a jump for the label at the top of our stack. Now we'll keep track of that by making sure we push that here. And increment it so that we'll have label 0, label 1, label 2, and these will all match up in our assembly. So we're going to jump to labels.top. And then we need a label to jump back to from here, our label end, which is going to be, pardon? Labels top, end.
Simon, on line 43, maybe you want a backslash n, not a forward slash.
Yes, I did. Thank you. Okay. And we need to pop our label off the top. So now we have matched up our begins and our ends, and this will all hopefully work out in the assembly. What do you all think about this code and the I/O streams interface in general? Any feelings?
Do you need a semicolon at the end of line 43?
Line 43, semicolon. No, I don't, because I'm just going to continue streaming to this outstream. It's just going to keep on working. I'm not really a fan of I/O streams in general. This looks really, really noisy. You know, I keep on having to have these chevrons and end my strings and then dump something in the middle. It's really not nice. Hands up if you're familiar with formatlib. Most of the room, that's cool. So formatlib is fantastic. It's a library which is hopefully going to make it into a future version of C++ in the standard, but currently you can use as an external dependency. So what I can do is I can use formatlib to essentially get Python-style formatting in my C++. So I can get rid of all of these chevrons and replace them with placeholders. Then all I need to do in here is say that I want to fill in these placeholders with current label. So this will fill in, this just means the 0th argument, which is current label. So I'm going to dump in, say, 0 or 5 or 12, whatever my label number is, here and here. Is everyone okay with that? Cool. And then similarly here, I can do format print to out, get rid of these, get rid of all this nonsense. And put labels.top as my argument. Okay, so that looks a lot better. I hope you'll agree. It's a lot more readable, understandable what we're actually trying to achieve. This is some label with a number, and then we have an instruction, and then we're jumping to label with a number and end. It's a lot easier to see what's going on. And especially if you have more complex formatting you're trying to do, this just makes so much more sense. The problem, however, is this red squiggle. I don't have formatlib installed, and now I have to do dependency management. So I said I'm going to use Vcpkg. One handy thing is I know what header I need to include. I know that format.ostream.h format /ostream.h is the header I need to include in order to do all the work which I've just done and had it compile and link. Of course, it cannot open the source file because I don't have it installed. I'll switch back to Windows for now. Helpfully, Visual Studio tells me that format can be installed with Vcpkg, and it even says it can copy the command to my clipboard. So I can go ahead and do that. I have Vcpkg already installed. So if I go paste this in, it's just Vcpkg install, format, and for 64-bit Windows. Hopefully, there we go. So I already had the package downloaded because I don't trust conference internet. But this is now building it from source and installing it in a known location so that any of my Visual Studio applications can find it. Or I can use it from GCC or Clang or anything, just might need a little bit more configuration. So that's all built already, but I'll go back and talk a little bit about Vcpkg itself. So this is an open source project developed by Microsoft and the community, and you can find it at GitHub. It's a package manager for C and C++ libraries, and it's cross-platform. It runs on Windows, Linux, and macOS. There are over 1,000 packages at the moment, and there's more added essentially every day. They're either contributed by Microsoft or they're contributed by all of you folks. So you can, if you have your own package or a package which you depend on and it's not in Vcpkg, you can write your own, they're called port files, to tell Vcpkg how to build and install this library, and then everyone can use it. You just issue a pull request into the GitHub repo here, and if it looks good, it'll get merged in, and everyone benefits. So this is kind of how the model works. Some nice things about Vcpkg. All the libraries and their dependency chains are tested. So if I have a given commit of Vcpkg, which has 1,000 packages all at some given version, I can know all those packages have been tested, and all their dependencies have also been taken from that package list as well. So the entire chain of dependencies is good, at least depending on how good their testing is. But it means you can be fairly safe in the knowledge that if I pull down this library, I'm not getting something broken. And that actually wipes out a whole stream of errors. You can export binary packages. So although Vcpkg, as I just showed, will build everything from source, you could do this, say, like on a build farm, and then distribute all the binary packages to your developers so that you don't have to build all your dependencies all the time. It supports private libraries. So if you have your own proprietary stuff, which you want to keep secret and no one can have, then that's supported. You just have your own fork of all the ports which are available, and you can put your own ones in there, and no one has to know anything about it. You don't have to tell Microsoft. You can just keep in your own world. You can and you should pin your dependency versions. So if you have a set of dependencies for a given version of your project, you don't want those to be upgraded under your feet, because that can cause problems. And this is a big issue with using system package managers for dependency management, because as soon as you upgrade some application, then maybe all your dependencies get upgraded, and now your library which you're developing is broken. So you don't want your dependencies to get updated without you asking for it, and you can do that with Vcpkg. So a little bit of a demo. So I already showed how to build something with it. And this handily gives us some CMake targets. So no matter what package it is, sorry, yes, question?
Is it possible to package non-native dependencies with Vcpkg, like Python package, or you're not supposed to do that?
The question is it possible to package non-native libraries like Python. I think you could do that. It's not the main. It's not the desired use case for the manager. So we got our CMake invocations here. We can steal the magic words and put them into our CMake. So I don't want the header-only version. Fix indentation. Okay, so now this is all I need to use format lib in my application. I just installed it through Vcpkg. I stole the necessary CMake instructions from what it told me, and now I should be good to go. So I'm going to tell CMake to regenerate, and hopefully this should go away. There we go. So now, if I scroll down here, again a little bit small, but this is the documentation for format lib, and I can write, say, format PR, and I get format print and vprint. I now have full IntelliSense, and it all just worked from Vcpkg. All I had to do is install Vcpkg, which is very, very simple, and Visual Studio just works with it. It's really nice. Last place I need to put format lib, as I mentioned, this the CL register. This is where Windows expects the argument for putchar to go, but Linux is a little bit different because it has different calling conventions. So I can do format print out. And then I can just give it an argreg. And then up here, I'll say if I'm compiling for Windows, then argreg is CL. Otherwise, argreg is DIL. That's where Linux expects arguments to go. End if. Okay. Another nice thing to note is that Visual Studio has recognized that we're currently building for Windows because Win32 is defined as 1. So it grays out, if you can see it very well. Yeah, you can. It kind of grays out this line here so you can focus on what you're actually building right now, and you can know that this will not be touched at all. If I flip to WSL, then this switches. So I now know that I'm on this branch of the ifdef. It's just a nice little visual feature. Okay, so that is, I hope, a working brainfuck to x86 assembly compiler, if everything has gone well. I now need to assemble and link. So that's going to be a little bit different on Windows and Linux again, because they have different file formats for binaries, they have different system linkers, so this is all going to be ifdeft, but it's fine. You could, of course, abstract this and do it nice, but I have an hour. Okay, so if we're in Win32, we're going to use NASM, the NetWide assembler, because it runs on Windows and Linux, and we can just use one assembly syntax. We don't have to bother about conflicting syntaxes, which is just a nightmare. So I can run NASM for Win64, and I'm going to generate a tmp.object file. Linux is going to be very similar. Instead of Win64, I'm going to generate elf64. I'm going to generate temp.o just because it's more idiomatic on Linux systems. Okay, so that should assemble my assembly into an object file. Now all I need to do is get an executable, for which I need to use my linker and link against libc. So again, ifdef Win32. So on Windows, finding these tools is a bit of a pain. So I cheated and made some environment variables. So my linker, I put in link64, and my universal C runtime library, I put in UCRT64. So this will get me my linker and my C runtime for Windows. And then my command I'm going to run. Using Subsystem on Windows is a pain. It really, really is. You have to essentially do a ton of quote escapes to get anything to work, but we'll make do. So for Windows, we need our linker. We need more quotes because Windows must have them. We're going to compile for console. Our entry point is going to be start. And we're going to compile temp.obj to hello.exe. Last thing we need is our C library. And I think we have enough quotes to appease the Windows gods. So we can format that with our linker and our UCRT. Run that. This stuff is kind of mechanical, but you have to do it if you want to get something working. Finally, on Linux, it's a little bit easier. We can just run Subsystem, LD, link against C library, we generated temp.o, and we're going to generate hello as our binary. And the last thing we need to do is use the 64-bit dynamic linker, and I just happen to know where that lives. Okay.
975. Do you miss a zero between curly braces, the placeholder?
Where's that, sorry?
975.
Line 75.
Placeholder zero?
No. So if the question was, I missed it. Did I miss a zero between here? No. So if you, I used zero inside that placeholder earlier because I wanted to use the same argument twice. So I had to say I want the 0th argument twice. If you just put nothing in between the placeholder, it will incrementally use. So this will use the 0th argument, and this will use the first argument. Okay. So the last thing I need to do is we're calling functions. We have some memory, but we haven't actually set up our stack or teared it down or anything. Yes, question?
With NASM, you've introduced a runtime dependency, and it's not installed by default, at least on Linux. So how do you specify this?
Oh, so the question is about, I'm using NASM as my assembler. That's mostly just so I can get something working because NASM runs on Windows and Linux. You could just use the assembler which comes with GCC, but it doesn't have the same syntax as the one which the Microsoft one works. So it's mostly just for sake of sanity. So the last things I need to do are create a prologue for my functions. And this is just going to set up my all of the memory which I need here, and make sure that we have all of the libc functions we need. So we need to say that our _start is going to be our entry point, so we need to declare it as a symbol. We're going to be calling some C functions, so we're going to declare them as external symbols. We're going to call exit at the end as well, so we'll put that there. Start is going to be our entry label, so we need to say we're going to put it in the .text section, which is where code lives. Not much more to go now. So we need to set up our stack, which is going to hold all of the memory. I said this tape is infinite. Unfortunately, we don't have infinite memory in computers yet, so I'm just going to pick 4,000. That sounds infinite enough, right? So I'll subtract 4,000 from RSP, which is the stack pointer. Now I need to zero it. Fortunately, x86 comes with what's essentially just a memset function, but as a single instruction, and I can call it like this. I can say, I want to write the byte 0, I want to write it 4,000 times, and I want to start at our stack pointer. Then we give the gorgeously named rep stosp, and this is our memset, essentially. Last thing is, I said that we want R12 to store our current pointer, so we'll initialize that to the bottom of our stack. And then we need to give a little bit more space in our stack for calling functions, so we'll just subtract some more. Can then write this out. And finally, I said we also need to tear this all down at the end. So our epilogue just needs to set the stack pointer back to where it was and call exit. There we go. Okay, so we need to reset our stack, which we do just by adding 4046, which is what we subtracted in the prologue. And we want to return 0 from the entire function, which we do by moving 0 to EAX and calling exit. Now we write this out. Okay. So if everything has gone well, which is a very, very loaded thing to say, then we can build for Windows, which I just did. We can now build for Linux. Building, linked, okay, great. We can go into WSL. We can run our compilers, which are in out/build. Wrong, yep. I need to go back to source. Here we go. Okay, I can run out.build/WSL. And this should generate me, there we go, hello, my binary. And this is what my assembly looks like. This looks like some fairly reasonable, at least valid, x86 assembly. So we've got our prologue at the top here. We've got all of our labels. We've got our label ends. And then all the way at the bottom, we should have our epilogue. So I ran the Linux compiler. Now I should be able to run the Windows compiler from the same command line. Oops. Okay, that compiled and it linked. So we now have hello and hello.exe. So if we can run both of them at the same time. Okay. Deep breath. Kind of get a drum roll. Hello world, hello world. Okay, so we just wrote an entire compiler in an hour. It worked miraculously. Here are some resources you can find if you want to learn more about any of the things which I talked about today, or you can come talk to me. I'm at Tartan Llama on Twitter. Come find me after, send me a message, enjoy the rest of the conference. Thank you. Any questions? 10 minutes, yep.
During configuration time, you chose WSL as a target.
Sorry, can you start again with the mic?
Yeah. So during configuration time, you chose WSL as a target, and you could have chosen Linux. What is the difference?
Oh, so the question is, yeah. So when I choose configurations, I could add these Linux targets as well. These are essentially, if I have like a remote Linux machine or a VM I set up or something which isn't WSL, but I still want to target, I can do that, and I would use the Linux targets for that. So the WSL ones are just if you want to target WSL and don't want to do any of that setup, but you can target like embedded devices or Linux desktop machines or servers by doing all of the SSH configuration yourself, essentially.
Okay, but I could generate for Linux and then run it into WSL, right?
Yep, yeah,
Okay.
you could do that. You could generate a Linux configuration, and then you would have to use the connection manager to set up your Linux, your connection into WSL and set up your SSH servers and things like that. So you could do that. It's just a lot easier to use the WSL configuration. Yeah.
Thanks.
How visuals did you handle the...
Sorry, wait. Thanks.
Hello. How visuals did you handle the line return on both environments?
How is that
Linux,
handle line return?
Windows. So basically, if I take this code and have it mounted somewhere in Linux, should I be worried about the cartridge return between both OS?
So do you mean if you're writing C++ applications, or if you're just using WSL and using a bash shell? And
I mean, cross compiling between Windows and Linux. I have the code in one place, and I have both compilers. Both Microsoft compiler actually cares about and GCC or otherwise cares what the line, the end of lines.
Do you mean the end of lines of your source files?
Yes,
or,
exactly.
Okay, the end of lines of your source files. Okay, I think you can handle that in. I can't remember in Visual Studio. In Visual Studio Code, at least, you can easily change the line endings. Yeah, I think it can be a problem if you're not like aware of it, but there are tools to help with that. So you can convert between the two with command line tools, or with Git hooks, or with your text editor, or your IDE. So as long as you're aware of when you do hit a problem, you know how to solve it. Then
the basic problem is when you do git diff.
Right. Yeah.
And
yeah, you can set up the editor to use Unix line endings.
Okay. Thank you.
So how would Windows Subsystem for Linux work with graphical applications?
Yeah, so WSL is only for command line applications,
Yeah.
so it doesn't work with graphical applications. You could maybe set up like X11 forwarding or something. I haven't tried it. I don't know if it would actually work. But yeah, if you want to do graphical applications, you're going to need to set up a VM and whatnot.
Okay. Another thing that might be nitpicking is in your code under the FMT namespace, you had curly pink, I guess.
Yeah, the purple lines. Yeah,
Right.
That's just IntelliSense and Vcpkg and WSL having a little not getting on very well with each other. It's just that will be fixed at some point. So yeah, the purple lines just mean that this is fine in this configuration, but in your other configuration it's not working. So it's not quite as bad as red lines, which mean it's broken right now. Purple lines just mean if you switch configurations, you're going to have problems.
Okay, thank you very much.
Yeah, hi. I understand it won't be magical, but how much work would you have to do to integrate another package manager, like, say, Maven?
What, you mean in Visual Studio?
Well, what would have to change in what you've done? Because this was a couple clicks, because it knows about.
Right. Yeah.
I understand there may be scripts, but how much work, how much additional work would it be to work with something beside Vcpkg?
Yeah. So Vcpkg, because it's a Microsoft tool, and we have spent a lot of time in Visual Studio making sure that integration is really nice. So with Vcpkg, it's obviously a few clicks, as you say. If you want to use like Conan or something like that, you absolutely could. You would just have to do. I wouldn't like to estimate how much extra work it would be, but you would have to do the configuration to make sure that Visual Studio knew where to find those libraries. You'd probably just need to hook up, make sure that CMake could find them. And then if CMake can find them, then IntelliSense can find them, and everything should be okay. But yeah, you would need to do a little bit extra work to use a different package manager. Any other questions? Yeah.
So, sorry. Here you starting a new project to show all these cool things to make cross-platform and use package management. What if you have already a big project with a lot of modules and your current build system and package management, you know it's bad, so you want to change? Will you start using these tools for one module and try to integrate it in the existing, or?
Yeah, absolutely. You could do this kind of thing iteratively. So, I mean, if you start using Vcpkg, it doesn't mean that you need to put all of your dependencies in there. If you have a huge dependency list, you can one by one move them over, test, make sure that you're still gold, and then eventually you can move everything over. You don't have to do it all just like one huge PR or something, because that's not going to fly most places.
And I have just a small follow-up question, because I'm working in embedded systems.
Mm-hmm.
Here, you have pre-made targets in Visual Studio for Windows, Linux, etc. If you were using a specific toolchain because you're compiling for a specific hardware, how hard would it be to add it to Visual Studio?
So if you have, do you have a CMake toolchain file?
No, it's more toolchain, the full library, the full libc with all the.
Yeah. So if you're doing cross compilation, what you really want is a CMake toolchain file, which sets up your sysroots and all your environment and has it all just in one script. And then if you have your own toolchain file, you can still use that with Visual Studio and with Vcpkg, and it will still work.
Okay. We don't have that because we're using OpenWRT, but we could change. Thank you.
Other questions?
Hello, thank you for the presentation. And the question would be about the different platforms. So you said, they said that the support is for Windows, for Linux, for macOS. What about, for example, Android or embedded platforms for Vcpkg? Can you also provide these packages?
Yeah, I think I'm not entirely sure about just how much all of that stuff is tested, because testing on these platforms and having all of that infrastructure is difficult. I think it's at least nominally supported, but maybe you couldn't necessarily just say, oh hey, I got everything and it works out the box and all of my libraries I need are working. You probably need to do some additional testing yourself. Other questions? Great, thank you very much.